Okay, so now we need to move into step 4, which is of course the most difficult part. And we'll do it again both ways just to show you. So we could have the classical method. Let me move this up. Which means we're going to need a critical value. We only need one because it's a one-tailed test. So if it was a two-tailed test, we'd need 2 of them. But since it's a one-tailed test, we only need 1 of them. Okay, and now this is a t distribution, so it's equal to t dot inverse. And the probability is 0.01. Now my degrees of freedom, I'm going to choose the smaller of these two, which would be 268 take away 1. Oops, okay, well that's not right. It's negative, which I don't really want. I forgot about that. So the t inverse is doing the left-tailed thing. So in order to get it to be positive, which is what we really want, you can do that 2 ways. You can do 1 minus 0.01 to give you the 0.99. That would work. Or you can leave it as 0.01, but then just do the opposite, negative, like that. That'll work. So the idea is this is a right-tailed test, so you need this critical value to be positive. And nobody can ever remember whether t inverse does left or right. So this one it's doing right, so just do, or excuse me, it's doing left-tailed. So you have to invert it somehow, either with a negative in front of the t inverse or with a 1 minus for the alpha right there in order to get it to work. But one way or another, it's got to be positive because it's right-tailed. If you have old school Excel, let's see, it's t inverse. All right, you need to take alpha and multiply it by 2 because the old school t inverse is always two-tailed by default. And then you want 268 take away 1. There. And that one automatically is the right one. So confusing, isn't it? Yes, I know. That's all right. It's just how it is. So the t inverse function is one of the worst functions to work with in Excel. Okay, so that's the classical method. And hopefully you can see if this is classical method, your step 5, you are totally going to reject H naught, right? All right, so reject H naught because your T0, which is your test statistic, which was 12.977, is greater than T alpha, your critical value, which was only 2.34, right? So, hold on, insert, there we go. Okay, so your critical value is saying, hey, I'll take up to 2 standard deviations away, and you are well past that with 12.977. Now the p-value way you can find by finding the area in the right tail, right? So new Excel, you can do t.dist.rt, right-tailed, right? And they say 12.977, comma, degrees of freedom was 268, take away 1. No, I know that's not really the degrees of freedom. That's how we're going to do it because the book mentions it. It's just a simpler form. All right. So there's the p-value right there. If you're doing it in old school Excel, I got to remember this. All right. So then you tell it 12.977. Degrees of freedom is 268, take away 1. And the tails is a one-tailed. Let's see if it works. Yep, there you go. So there's new Excel is .rt, and then old Excel is just tdist. And you can see you're rejecting H naught here. Oopsie, because P is, that's really small, right? It's 29 zeros and then a 1. So P equals 0.000 essentially is less than alpha, which was only 0.01. And of course, we could also do this in StatCrunch. Let me bring it up. Here it is. So I just typed it in just to have it. Actually, I copied and pasted, to be honest. And then I'm going to go t-statistics to sample with summary. I don't have data for this particular one. And then you got to be careful. You want the community college one to go first, right? So it was 5.43, 1.162. Hold on, I'll type this in. Turn off the pooled variances. It was a right-tailed test. Calculate. There it is. Same numbers we came up with.